everyone. Let's study a new chapter, time value of money. In this chapter, we have the following important topics that we need to cover. Number one, we need to study the concept of future value. Number two, we need to study the concept of present value. Three, we're going to study annuities, including ordinary annuity and annuity due. Number four, we're going to study uneven cash flows. Number five, we're going to study the compounding frequencies and the effective annual rate. Number six, we're going to study the loan amortization. So let's start with our first topic, the future value. Now, before we go on to study the future value, we need to ask one question. What is the time value of money? Why is there time value of money? Now, you're supposed to receive your salary today, but for some reason, your employer approach you and ask if they can pay you a year later with the same amount of salary. Well, of course, you would not like the idea, because if you receive that today, you can consume the money, paying bills, or buy stuff you want. Or you can save the money in the bank that earns an interest rate. So by postponing the payment, you miss out the opportunity that you could earn some interest on the salary payment. So this is the time value of money. So the money you receive today is valued differently than the same amount of money you received a year later. So that's why we say there is a time value of money. Now, there are some important concepts that we need to get familiar with. Let's look at our example. Suppose we can save $100 in a bank account that earns 10% compound interest every year for 3 years. Now, after saving the money for 3 years, how much money will you have in that bank account? Well, first, finding the future value of some cash flow or series of cash flow is called compounding. That's a process of compounding. Now, finding the present value of a cash flow or series of cash flows is called discounting. So finding the future value is called compounding. Finding the present value is called discounting. Whether you are looking for future value or present value, the best practice is always draw your timeline. So on the timeline, you will mark your cash flows at exactly when it happens. So in our example, you're going to deposit $100 today and save that money in the bank account for 3 years. Every year, that money will be earning 10%, and the interest rate is compounded yearly. So after 3 years, how much is the future value? And on the timeline, we have our $100 deposit at time 0, and then we're looking for the future value after 3 years. How do we calculate our future value? Well, it's a process of compounding. So first, let's take baby steps. Let's solve the future value step by step and using the formula. So to solve the future value after 3 years, let's solve the future value after we save that $100 in the bank account for 1 year. So 1 year later, how much money do we have in the bank account? Well, we saved $100 for 1 year, which earns 10%. So 100 times parentheses 1 plus 10%. And a year later, we will have $110. Now, 2 years later, how much money do we have? Well, after 1 year, we have $110, right? and this $110 will be earning 10% again in the second year. So it's 110 times 1 plus 10%. That will give us $121. Or using algebra, it will be the $100 which we saved or deposit in the bank account at time 0 times 1 plus 10% to the power of 2. So that will also give us the same answer, $121. Now, after 3 years, how much money do we have? Well, 2 years later, at the end of year 2, we will have $121, and that will keep earn 10% for another year. So it will be 121 times 1 plus 10%, which will give us $133.10. Or we can do this. At the beginning of this timeline, at time 0, we saved $100. That'll be earning 10% every year for 3 years. So 100 times 1 plus 10% to the power of 3. That will also give us the same answer, $133.10. So the future value of this $100 deposit at time 0, which earns 10% compound interest every year for 3 years, will be $133.10. And also, we get the generalized formula for future value, which is the present value. In this case, we also get the generalized formula for present value, which will be the present value. In our example, that's that $100 deposit at time 0 multiplied by parentheses 1 plus the compound yearly interest rate. In our example, that will be 10%, and then close the parentheses, reset to the power of n, and in this case, it will be 3 because we saved that for 3 years. And that will be 100 times parentheses 1 plus 10% to the power of 3. That will give us $133.10. So that $133.10 will be the future value. That $100 deposit at time 0, it will be the present value. And given the future value, how do we solve a present value? Also, we have the generalized formula. The present value will be future value divided by parentheses 1 plus the compound annual interest rate, and then close the parentheses, raise that to the power of n. In this case, it will be $133.10 divided by 1 plus 10% to the power of 3. So backward, we can solve the present value, which gives us 100. Now, the alternative ways of calculating present values, future values, rather than using the generalized formula, is to use financial calculator or Excel spreadsheet. Use the financial calculator. Here, let's teach how to use TI BA2 Plus financial calculator. TI stands for Texas Instrument. BA stands for Business Administration Type 2 financial calculator. So on the financial calculator, first, let's type in a number 3, which is the number of years we're going to save the money. And then press the function key N, which stands for the maturity or number of years. So on the financial calculator, if we use these function keys like N, IY, present value PV, payment PMT, or future value FV, we always type in the value first and then press the function key to assign the value to the financial calculator. And if you do it backwards, that's going to mess up your answer. So value first and then function key. Again, 3 for N, and then 10% for IY. But in the financial calculator, you always forget the percentage when you enter the interest rate. So here we only enter number 10 and then press the I/Y key. That means interest slash yield. And then the present value will be 100. So type in 100 first and then press the PV key, which stands for the present value. The next value is the payment. Here, we do not have an annuity or a series of payment. So that will be 0. So type in the number of 0 and then press the PMT key. PMT stands for payment. Now, we can solve the future value by pressing the compute key, CPT, which is on the top left-hand side of corner on the financial calculator. And then press the future value key, future value FV. You should get 133.10. And some of you might notice that 133.10, the answer you get has a negative sign in front of it. This is very good because you are paying attention to the details. Well, why does the calculator gives us a negative outcome or negative answer? Here, the negative sign means the direction of this cash flow, that $133.10, is different than the direction of the cash flow of the present value, which is that $100. Remember, we entered positive 100 as the value of present value, right? So here, the calculator has this logic. When you have a positive cash flow as the input, the output gotta have a different sign of the cash flow or direction of the cash flow. So if the present value is positive, then the future value must be negative, because these two cash flows actually are the same pile of money. You put in $100 in the bank account at the beginning, and then you take out $133.10 at the end of year 3. So this is actually the same pile of money. It's not two different piles of money. That's why the future value has a negative sign, because it means the direction of this future value is different than the direction of the present value, 100. And the Excel spreadsheet has a built-in function calculating future value. So in the Excel spreadsheet, pick a cell, then type in equal sign, and then future value, FV, and then in the parentheses, these are the parameters. 0.1 or 10% as the interest rate. Here, the Excel treated the interest rate differently than the financial calculator does, because financial calculator ignores the percentage. The Excel spreadsheet never ignores the percentage. So you need to enter 10% of 0.1 as the interest rate. And then use a comma to separate. The next value will be the number of years. So 3 for the number of years or maturity. And then comma again. The next value will be the payment, which is 0. And then comma one more time. That separates the next value, which will be 100 is the present value. And then close out the parentheses and then press the enter key. You will also get the future value, $133.10. So that's how you use the Excel spreadsheet to calculate the future value.